Let's continue with the previous session what we have covered in the last class. So let's start with the previous session, previous class topic, then move to the today's topic, that is the event driven model. So first of all, take a quick review of the last class. In the last class we have started with the concept, that is the Windows programming model. Till now we have discussed about the DOS programming model, then we have discussed about the Windows programming model. So there is a difference between the DOS programming model and the Windows programming model. The main difference is that in DOS programming model, that is based on the CUI, that is character user interface. Every user, every C programmer have to remember each and every command of the DOS. But in Windows programming, it is a GUI, that is graphical user interface. Each and every programmer does not want to or does not have to remember each and every command, but simply drag and drop facility, simply capture the command and do the transactions as they need. So this is a Windows programming model. So this provides an interface of the graphical user interface from the typical text interface that MS-DOS offer. So this involves a switching of the graphical user interface from the typical, that is a traditional text interface that the MS-DOS provides. And whatever the limitations of DOS programming models, like messy calling mechanism, inconsistent look and feel, hardware dependent or dependency, so all that limitations are removed by this one, that is a Windows programming model. So this Windows programming model provides the features that are the limitations of the DOS programming model. So this says DOS programming model is designed with the VO2. What are the reasons why it is designed? It is designed with a view to eliminate the messy calling mechanism of DOS, permit true reuse of the commonly used functions, that is proper usage of the commonly used functions, then provides consistent look and feel for each and every application, that it provides a good that is a consistent means a similar look and feel for each and every applications, then eliminates the hardware dependency. That is, it also eliminates the hardware dependency, that is every C program is not dependent on the hardware, but they are independent of the hardware, that is they can execute, or programs can execute on each and every system. It depends on the operating system, not on the hardware. Then we have discussed about each and every term, that is how to or what are the features of Windows programming model, that is how it provides a better calling mechanism, how it provides the reuse of the commonly used functions. So this says better calling mechanism, that is instead of calling functions using interrupt number and registers, Windows provides function within itself which can be called using names. These functions are known as API. That is whenever there is a calling mechanism, that calling mechanism is provided by the API in Windows programming model, that is your application programming interface. Then the next feature is the true reuse, that is the true reuse, that is the API function uses several, or C programs uses several API function that is or that is used during the execution. So there are so many exe file that is used. So there is one concept that is known as or there is one special file that is that have extension .dll, that is dynamic link library, that is used for dynamic link libraries, and that is a binary file that provides a library of functions, or that combines various variety of library of functions. That is a tree reuse, that is multiple exe files are combined into one DLL, and that is provided by the Windows programming model. So if I want a one library function, I can use the DLL. If you want the one exe file or one function library function, you can use the DLL. So these functions can also be shared between several applications running in the Windows. So these are the two reasons why we are using the DLL. First of all, sharing common code between different executable files. So if there is a common code, so we can simply share that common code by using the DLL, that is a .dll. Next point says breaking an application into component parts to provide a way to easily upgrade application components. That also provides a way to break an application into various components to provide a way to easily upgrade the various components of the application, that is your application components. The Windows API function comes in 3 DLL files. That is, window API comes in 3 DLL file that can be explained by using this table. This is the most important table that we have discussed. One is your user32.dll that stores or that contains the function that are responsible for the look and feel, that is window management, menus, cursors, communication, timers. That is a look and feel that is stored in the user32.dll. Then GDI32.dll that also provides a DLL function that contains the functions for graphics, drawing and painting. Then kernel32.dll that also contains the function to handle memory management, threading, etc. Then the next feature that is provided by the Windows programming model is the consistent look and feel. As I told you, consistent means the same. That is, every program offers a similar look and feel, similar user interface. So there is no confusion among the interface. Every program occupies a window, rectangular screen on the area on the screen. Every window is identified by the title bar. Every window has a scroll bar. Every window has a status bar. Means everything is the same. That's why this provides an advantage, that is a consistent look and feel. Then the next feature that is provided by the Windows programming model is the hardware independent programming. That is, every program is not depend on the hardware, but they are independent of the hardware. That's why it is known as the hardware independent programming. Therefore, an application can easily communicate with the OS. That is, there is no requirement of the device driver. They simply the operating system communicate with this one. That is your device application programs. So there is no way to, or there is no requirement of the device driver. Simply OS communicate with the various programs that is provided by the C language, right? So these are the various application, or these are the mechanism that of how it is providing the, or how OS directly communicate with the application. So this is the OS and this is the application. There is a direct communication between the OS and the application. These are the various things that is required in between, that is the hardware, device driver, Windows application. There is a API call, there is a message. Then next topic is your event driven model. That is the today's topic. So till now we have covered Windows programming model, that is what is the use of Windows programming model and why we are using the Windows programming model. What are the advantages of Windows programming model? Means every limitations of the DOS programming model becomes all the disadvantages of the Windows programming model becomes the advantages of the Windows programming model. Now let's start with the today's session, today's topic, that is the event driven model. Now, what is event-driven model? This is when a user interacts with Windows programs, a lot of events occurs. That is, whenever I operate a Windows, I am a user, so I interact with the window program. A lot of events can occur, or a lot of events occurs. For each event, a message is sent to the program, and the program reacts to it. That is, for each and every event, a message is sent to the program. A message is given to a program and the program reacts to it, or program reacts to this message. Since the order in which the user would interact with the user interface elements of the program cannot be predicted, the order of occurrence of events, and hence the order of images also become unpredictable. That is, the order in which the user would interact with the user interface elements of the program cannot be predicted in the advance, or cannot be predicted the order of occurrence of the events, and hence the order also becomes unpredictable. That is, no prediction of the order, and that becomes unpredictable. As a result, the order of calling the function in the program is dictated by the order of occurrence of events. That is, whenever we call the functions, that order is provided by the order of occurrence of events. Suppose event occurs for 5 times. So this order, or this calling mechanism, is also dictated or also used by the order of occurrence of the events. Hence, this programming model is known as the event-driven programming model. Why event-driven? Because as soon as the event occurs, there is a calling of the function in the program. So a function will be called in the program. So that's why it is known as the event-driven programming model. That is, on the basis of event, there are various mechanisms, there are various calling functions that is called whenever there is a occurrence of the events. Hence, this programming model is known as the event-driven programming model. That's really all that is there to event-driven programming. Your job is to anticipate what users are likely to do with your application user objects and have a function waiting ready to execute at the appropriate time. Just when that time is, no one except the user can really say. So this simple terms, whenever your turn comes, whenever CPU is free, you can execute the program. That is also based on the event. So that's why it is known as event-driven programming. Now, the next topic is Windows programming, a closer look. That is, let's take a quick review of the Windows programming, how Windows programming will be done. This is, there can be hundred of ways in which the user may interact with an application. There are so many ways, or there are hundred of ways in which the user can interact or user may interact with an application. In addition to this, some events may occur without any user interaction. That is, there are some events which can occur or which may occur without any user interactions. That is, there are some events which may occur, which you can occur or which maybe or may occur without any user interaction. For example, event occur when we create a window, when the window's content are to be drawn, etc. That is, event occur. Event means a condition, a scenario whenever we do something. So an event occur when we create a window, when the window's content are to be drawn, etc. That is, window occur even when we create the window, when we use the window, when the window content are drawn, when we use the menus, etc. So every time an event occurs. Not only this, occurrence of one event may trigger a few more events. That is, when one event occurs, that also becomes, or that also triggers, or that also replicates a few more events. Therefore, literally hundred of messages may be sent to an application, therefore creating a chaos. That is, there are so many applications, there are so many messages that can be sent, or there are hundred of messages that can be sent to an application. So that becomes a hodgepodge, or they creates a chaos. That is, they become a hodgepodge condition. Naturally, a question comes: in which order would these messages get processed by the application? A question arises, or question raised, that is, in which order messages get processed by the application. Suppose there are 5 messages, or suppose there are 5 events. So in which order they are, or in which order they are processed by an application? The order is brought to this year by putting all the messages that reach the application in a queue. So whenever the event occurs, they are putting into a queue. That means one after the another. The messages in which the queue are processed is known as the FIFO. So FIFO is a concept that is based on the queue. What is FIFO? In simple terms, whenever we use a queue, that means a line, that means the first event that occurs, or the first event that enter in a queue, is the first event that removes from the queue. That is first in, first out. Suppose there are 5 events. The first event occurs first, so the first event will be first out, not the last event. So that is based on the FIFO, first in, first out. In fact, the operating system several such queues, or operating system also uses such queues, that is first in, first out. Whenever a first condition occurs, the first will be out. There is only one queue which is common for all the applications. This queue is known as system message queue. So that queue is known as the system message queue, in which we can maintain the queue, that is one event can occur, we can compile to the next event. In addition, there is one queue per application. Such queues are known as the application message queue. So one is queue that manage, or that is common for each and every application, for all the application. and there is one queue per application. Such queues are known as application message queues. So one is system message queue, that is common for each and every application, for all the application. One is application message queue, that is unique for the application. Now let us understand the need for maintaining so many queues. That is why, what is the reason for maintaining queues? This says when we click a mouse and an event occurs, the device driver posts a message into a system message queue. So whenever an event occurs, or whenever we do something, we perform or we give input, we click a mouse, an event occurs, the device driver posts a message into a system message queue. So there is a system message queue which is used. The OS retrieves this message, find out with regard to which application message has been sent. So it is a responsibility of the OS to find out for which application or for which event or for which scenario this event can occur. So first of all, it is sent to the system message queue. Then OS retrieves the message and find out the application for which it was sent, it has sent. Next, it posts a message. It means the operating system posts a message into the application message queue. So first is system message queue, then OS searches or look for the message, then send to the application message queue of the application in which the message or in which the mouse was clicked. This is figure 16.5. There is an event. This is also an event. This is using keyboard. This is using mouse. There is a device driver. There is a device driver. Both the way the message is coming into, first of all, system message queue. Then it is the responsibility of the OS to decide into which application this event has gone. This is one message. This is one message. Application 1 message queue, application 2 message queue. This is one application that is running, that is using the notepad. One is one application that is using the C++. So this is the diagrammatical representation of the Windows programming. I'm repeating again. There is an event. For example, event is carried out with the help of the keyboard or mouse. So this is the keyboard. This is the mouse. Both are used to give the input. So both are based on the event, or both are the events. Then there is a device driver. That is, device driver means there is a device driver that is used to communicate with the event with the hardware device. There is a device driver and there are two messages, or there are different messages. Two messages that are compiled into or that are cluttered into the system message queue. Right. Now it is the responsibility of the operating system to divide that message into multiple parts, into multiple applications, into different applications like application 1, application 2. For example, in this example, the OS divides the message into two parts. One is application 1, one is application 2. This application 1 is based on the notepad. This application 2 is based on the C++. So this is the scenario how it will be used. I think now we have covered enough ground to be able to actually start C under the Windows programming. Here we go. That is, we have prepared one base. Till now you have prepared, this book has prepared one base on which the applications are running. Now this is the time to use the first Windows program. That is, how to use or how to execute the first Windows program. To keep things simple, we should begin with the program that merely display a hello message in a message box. Here is the program. This is the program. That is #include windows.h. So first of all, window.h is a header file that is used. That is a header file that is included with the #include. So #includes windows.h. Now uses the int underscore std call, then win main. So win main is the name of the function. Std call, then there is a int. So integer is a type, data type, underscore std call, then win main. Win main is the name of the function. Then uses instance, h instance, the variable is h instance, then h instance, the variable is h preference, then lpstr, The variable is lpsg cmd_align, then int cmd show. So these are the various arguments, these are the various variables that is declared over here. That is bin main, cmd show. Now uses the curly braces for this one. Then there is the message box, right? Message box is used to display the message. There is a 0, there is a hello, there is a title, there is a 0. So this is 0, that is H instance. Then privilege instance contains the hello. Then lpstr contains the title. Then cmd show contains the 0. This is return 0. Normally or naturally, a question arises in our mind: how do I create and run this program? And what output does it produce? So obvious. You think also, I think also, how this program will execute? What is the output? What is the key? How we can process, how we can execute this code? So firstly, take a look at the output that is produces. That is, this is the output that is produced. There is a title, there is a hello. So hello is the word that is written over here. This is the title bar. Then there is a button that is known as the OK. This is figure 16.6. Now let us look at the various steps that one need to carry out to execute this program. So this is the output, right? This is the title, this is the hello, this is the OK button. Now what are the steps? How this will be executed? The first step is start the VC++ from the start program C++ 6.0. For example, this is the Turbo C++ for Windows 7. This is not C++ or this is not that one. That is Visual C++ 6.0. The VC++ ID window will be displayed. From the file, get on the new, select Win32 application. So these are the various steps you have to compile if you think, but if you don't think, simply remember all these things. So from the file, go to the new menu, select Win32 application and give a project name, say for example sample1, click on the OK. So go to the C++, click on the file, click on the new menu, select the Win32 application, give a project name, for example sample, then click on the OK button. Then again from the file, or go to the file, click on the new menu, select C++ source file and give a suitable file name, say for example sample1, and click on the OK. Right. Now the Win32 step 1 of 1 window will appear. So this is like a wizard. There are various steps. So this is first step, that is step 1 of 1 window will appear. Select an empty project option and then click on the finish button. That is select an empty project option. This is an empty project option and then click on the finish button. A new project information dialog box will appear. So this is a new project information dialog box that appears. Close it by clicking on the OK button. That is simply close it by clicking on the OK button. Again select file, go to the new, go to the C++ source file, give the file name as the sample.c, then click on the OK button. So again go to the file, go to the new C++ source file and give the name of the file as a sample1.c, then click on the OK button. Type the program in the sample1.c that gets opened in the VC++ IDE. So type the name of the file as a sample1.c. This is an example. You can give any name that gets opened in the VC++ IDE. Now save the file using save option from the file menu. So first of all uses the new option from the file menu, then uses the save option from the file menu for saving a file. Now to execute the program, to execute this program, following are the steps that is mentioned below. From the build menu, so uses the build menu, select build sample1.exe. So uses the build menu, select the build or select the command that is build sample1.exe. assume that no errors were reported in the program, select execute sample1.exe from the build menu. So first of all, uses the build menu, then select build sample1.exe, then assume that no errors were reported in the program, then simply select execute sample1.exe from the build menu. Now let us now try to understand the program. The way every C under DOS program begin its execution with the main function. Every C program begin with the execution with the win main function. So this is the win main function that is used. So every C under Windows program begins with the this function, that is a win main, just as we done in the C program, that is the main function. Therefore, win main becomes the entry point for the Windows program. So this is just similar to that one. This is just similar to this one. That is how we are using for simple programs, or for R programs we use the main functions. For Windows programming, there is a function that is known as the win main function, that is becomes the entry point for the Windows program. So one is main, one is win main. A typical win main function look like this. So this is the typical win main function, that how it looks like. This is int std call win main. So these are the various argument that is used, 1, 2, 3, and there is a 4. So these are the 4 argument that is used. There is a variable type, there is a data type, there is a variable, right? Note that the underscore std call before win main, that is we can use the std call before win main. Why? What is the use of this one? It indicates the calling convention used by the win main function. So it indicates the calling mechanism. Why we are using this? What is the use of this one? So it indicates the calling convention used by the win main function. Calling convention indicates 2 things. What are the 2 things that indicates? The order, that is left to right or right to left, in which the arguments are pushed into the stack when a function call is made. So it depends on the arguments, how it is pushing into the stack, how it is going into the stack when a function call is made. Whether the caller function or the called function removes the argument from the stack at the end of the call. So there are two calling mechanisms. There are 2 things that must remember. One thing is that whether the caller function or the called function removes the argument from the stack at the end of the call or not, or the order in which either the program uses the left to right, or program uses the left to right or right to left. Out of the different calling conventions available, most commonly used convention are this one, that is underscore cde cl underscore std call. Both these calling conventions pass arguments to the functions from right to left. That is, both these mechanisms uses the or passes the functions or passes the argument to the function that is from right to the left. In cde cl, the stack is cleaned up by calling a function, whereas in case of std call, the stack is cleaned up by the called function. So one is calling function, one is called function. By using the std call, it is cleaned up by using the called function. One is cdecl. This is used for cleaning the stack by using the calling function. All API functions uses this one, underscore std call calling convention. If not mentioned, this one calling convention is assumed by the compiler. This is in this program it is not written, I think. Yes, so it is assumed by the compiler itself. Then what is the use of the h instance lpstrs? So this is h instance and lpstr are nothing but the type def. So these are the type def. As I told you, type def are the keywords that is used to give an alternative name to the data types. So these are nothing but the type def. The first is an unsigned int and the second is a pointer to a char. So H instance is simply a unsigned integer, and the second one, that is lpstr, is a pointer to a char. These macros are defined in windows.h. So these macros means the H instance and the lpstr are defined in a windows.h. This header file must always be included while writing C programs under Windows. That is, this file is always be included in a C program whenever we write the C program under the Windows. So H instance, H prev instance, lpsg, cmd show are simple variable names. In place of these, we can also use ijkl respectively. There is no hard and fast rule that we can or we are using these typical names. No, we can also use ijkl, anything, any name of the variable. But H instance, lpstr are nothing but the type def, and these are the various variables. Now let us understand the meaning of each parameter one by one. First of all, there is a win main that receives 4 parameters which are ascender. As I told you, this is the win main. This contains 4 parameters, 1, 2, 3 and 4. One is H instance. This is the instance handle. That is how to handle the instance for the running application. Windows creates this ID number. This ID number means instance handle ID number when the application starts. We will use this value in many Windows functions to identify an application data. So we will use this value value in many Windows functions to identify an application's data. That is application's data. A handle is simply a 32-bit number that refers to an entity. So instant handle means simply a 32-bit number that refers to an entity. This entity could be an application, window, icon, brush, cursor, bitmap, file, device, or any such entity. So handle is nothing but a 32-bit number that refers an entity, and entity could be any application, whether it may be Windows, whether it may be icon, brush, cursor, bitmap, anything. The actual value of the handle is unimportant to your programs, but the window module that gives your program the handle knows how to use it to refer to a entity. That is simple how to use the instance that is provided by the instant handle, and handle is a 32-bit entity that refers to an entity. The entity may be the Windows, the interface, the icon, and anything. What is important is that there is unique handle for each entity. This is the most important. That is, there is unique handle for each entity, and we can refer and reach the entity only using its handle. Then next category is H prev instance. That is the H previous instant. This parameter is a remnant of earlier versions of the Windows and is no longer significant. So this parameter is a remnant of the earlier versions of the previous versions of the Windows and is no longer in use. That is no longer significant or important. Right. Now it always contains a value 0. That is it contains a value 0. It is being persisted with only to ensure backward compatibility. So it is used with the persistent and only is used to ensure the backward compatibility. That is how it is compatible with the backward or the previous instant. Now next part is lpsg cmd line. This is the pointer to a character string containing the command line argument. As I told you, there is a command line argument like argc, argv. In the same way, this is the pointer to a character string. That is, it is using the pointer to a character string that combines or that contains the command line argument that is passing to the or that is passed to the function. As I told you, this is very similar to the argc, argv parameters that are passed to the main in a DOS-based program or in a DOS program. Then there is the ncmd show. This is an integer value that is passed to the function. Why it is an integer value? Because in a program it is already defined like this one. This is int cmd show. So this is integer value that is passed to the function. This integer tells the program whether the window that it creates should appear minimized as an icon, normal or maximize when it display for the first time. So in simple terms, it is used for the showing the window whether the window will be shown as a minimize, close, maximize, normal and anything that is covered under the CMD show. Then the message box function that pop up some message box which title its title or title is title, that is whose title is given as simply a title and which contains a message hello. So that is done by the message box. Returning 0 from the win main indicates success, whereas returning a non-zero indicates failure. So this is a program. So these are the various instances. This is the main entry point. This is the calling mechanism. This is of integer type. These are the various variables, that is instance handler, previous instance handler, LPG CMD line that is used for writing into the characters or the commands. Then int cmd show, that means uses the integer value for showing on the screen whether the window appears in a maximized form, minimized form, icon or when it display for the first time. Then this point says instead of printing hello in the message box, we can print the command line argument that the user may supply while executing the program. The command line arguments can be supplied to a function or program by executing it from start, run as shown in figure 16.7. So instead of printing the hello in the message box, we can also print the command line, or we can also print using the command line arguments that the user may supply while executing the programs. By simply executing by using the start, then go to the run, then go to this one. This is the type the name of the program, folder, document. This is by the run or the window. Now type C myapp exe abc ijk xyz. So any file. Note that the figure 16.6 that myapp.exe is the name of our application, whereas abc ijk xyz represent the command line arguments. So myapp.exe is the name of the application, while others are known as the command line arguments. The parameters lpsjcmd line points to the string, that is, it points to the string abc ijk xyz. This string can be printed using the following statement. So this string can be printed using the following statements. How it can be printed? By using this one, that is message box 0 lpsg or sj cmd line title 0. So this is 0, this is lpsg cmd line, this is the title that is displayed on the title, then there is a 0. If the entire command line including the file name is to be retrieved, we can use the get command line function. Now next one is your Hungarian notation. This is a same concept. This is the last topic, but I have to cover this topic after the break. So first of all, let's take a break, then cover this topic, so this chapter will be finished. So first of all, let's take a break for 10 to 15 minutes, then come back starting with this topic. So let's take a break. So let's continue with the next topic. So come back from the break, continue with the next topic, that is the Hungarian notation. So let's start with this topic. So this says Hungarian notation is a variable naming convention. So it is the honor of the legendary Microsoft programmer. So it is the way how it is a method how by which we can declare or we can name the variable, or that's why it is known as the variable naming convention. So it is the honor of the legendary Microsoft programmer Charles Simeoni. So this is the Charles Simeoni who brings the concept, that is a Hungarian notation that is used to define the variable, that is used to give the names of the variable. So that is why it is known as variable naming convention. According to this convention, the variable name begins with a lowercase letter or letters that denote the data type of the variable. So according to this convention, according to this method, according to the Hungarian notation, the variable names always begins with the lowercase letters or the letters that denote the data type of the variable. For example, the SJ prefix in the SJCMD line stands for string terminated by the 0. So this is the string that is terminated by the 0. That's why it is used SJ or SZ. So that means string that is terminated by the 0, and the prefix H in the H instance stands for handle. In the same way, N in the NCMD stands for the integer. So prefixes are combined to form other prefixes like LPSJ, that is long pointer to 0 terminated string, or long pointer to string that is led to or that is terminated by the 0. So this is long pointer to a 0 terminated string. Though basically this notation is a good idea nowadays, its usage is discouraged. This is because when a transition happens from say 16-bit to 32-bit code, then a whole lot of variable names have to be changed. That is, whenever there is a movement from 16-bit to 32 bits, a whole lot of variable names has to be changed. For example, suppose the 16-bit code use 2-byte and 4-byte integer variable known as the W param and the I param, where W indicates the 16-bit word and the 32-bit words respectively. When this code is ported to a 32-bit environment, this has changed to the I param. So one is W param, that is either of 16-bit or 32-bit, and when this is converted into 32-bit environments, its name has been changed to the I param, since in this environment every integer is 4 byte long or 4 bytes long. You should agree, or you would agree, that if we follow the Hungarian notation, then we would have to make a whole lot of changes in the variable name when we port the code to a 32-bit or 64-bit environment. So there are two concepts, one is W param, one is I param. W param is basically a 2-byte and the 4-byte integer values. W param is of 2 byte and I param is of 4 bytes. Right, and this is equals to 32-bit or 16-bit, 64-bit environment. Hence, the usage of this convention is nowadays discouraged. Therefore, the usage of this convention is discouraged nowadays. Now, summary. So this is Hungarian notation. In simple terms, whenever we have to declare the variable, we have to give the name to the variable. So this is a variable naming convention that is used or that is describes the Microsoft programmer Charles Simeoni Hungarian or Hungarian notation. For example, SJ stands for string terminated by 0, H instance stands for handle, NCMD stands for int, and so on. So these are the various prefixes that is used with the or along with the various programming variables. In the same way, W param, in the same way, I param. Now, let's see about the summary. The first point says under Windows an integer is 4 bytes long. So whenever we use the Windows, an integer value or integer is a 4 bytes long. To use a 2-byte integer, pre-qualify it with short. So whenever we use the Windows, integer is of 4 bytes long. Whenever we use the integer in Windows, it is of 4 byte long, not as we done in the C programming that integer takes 2 bytes. No, it takes 4 bytes. So under Windows it is of 4 bytes long. To use a 2-byte integer, pre-qualify it with short. So whenever I have to use it with a 2-byte, so we have to pre-qualify, we have to use or we have to specify it with the short, that is HHO or RT. Second point says under Windows a pointer is 4 bytes long. Next point says, so these are very summary that we have discussed. Next point says Windows programming involves a heavy usage of typedef. So whenever we use the Windows programming, it involves a usage of the or heavy usage of the typedef. Then DOS uses a sequential programming model, whereas Windows uses a event-driven model. That is, whenever we use the DOS programming model, that uses a sequential programming model, and whenever we uses the Windows, that uses a event-driven programming model. Next point says entry point of every Windows program is a function that is known as the winmain. So winmain is the entry point from where the Windows program is starting up, or where Windows program is starting with. Then next point says Windows does not permit direct access to memory or hardware devices. That is, Windows cannot provide direct access to the memory or hardware devices. They uses the device driver for communication with the hardware, or for communication with the memory and the hardware devices. So there is a device driver along with this. Next point says Windows uses a demand-based virtual memory model to manage the memory. So every window uses a demand-based virtual memory model to manage the memory. Next point says under Windows, I'm just coming within 2 minutes. Next point says Windows uses a demand-based virtual memory model to manage the memory. So it uses a virtual memory to manage the memory, how the memory will be circulated among various parts. So it uses a virtual memory concept. Next point says under Windows there is two-way communication between the program and the operating system. So whenever we use the Windows programming model, there is two-way communication between the program and the operating system. Like operating system communicate with the program directly, but there are various hardware, various application program, various device driver that is used in between. So that provides a two-way communication between the program and the operating system. Next point says Windows maintains a system message queue common for all the applications. So Windows uses or maintains a system message queue that is common for each and every application. Then Windows maintains an application message queue per running application. So Windows maintains or uses an application message queue that is used by per running application. So Windows also maintains a system message queue that is common for each and every application for all the applications, and Windows also maintain an application message queue that is used for each and every application individually. Then calling convention decides the order in which the parameters are passed to the functions and whether the calling function or called function clear the stack. So it depends on the calling convention that decides the order in which the parameters are passed, or whether the calling function or called function clear the stack. Commonly used calling function are std call and the cdecl. Then at last there is a Hungarian notation that is too good, its usage is not recommended anymore. Why? Because it is a calling convention, there are so many keywords that is used, there are so many prefix that is used over here. That is a Hungarian notation. Now there is a exercise. This is the exercise for this chapter. MS-DOS uses the procedural programming model, true or false? The answer is your false. Why? Because it does not use a procedure programming model. API functions under Windows do not have any names. Those functions are known as using interrupt mechanism. One of the parameter of Windows is this one is no longer relevant. So these are the various questions, various true-false questions, and these are the various theoretical questions. Now this is the examples, or these are the various programs. Now next next chapter is the Windows programming, that I will be starting in the 26th of class. That is tomorrow is no class because tomorrow is Christmas. So I'm going to start after day after tomorrow. So day after tomorrow. So let's continue with the practical approach right now. Larry, are you able to hear me? Yeah, Larry, are you able to hear me? Okay. So Larry, if you think that you want to wind up this class to means early, because tomorrow is Christmas, I know, and this is your main festival. So if you think so, so you can tell me. I can shrink the class. If you think no, don't think so that there is no requirement, so I can continue this class to the 5:50 as per the IST. If you think so, I can squeeze the class. I can shrink the class. Because you are the only student in the today's class, because I know tomorrow is a Christmas. So tell me if you want, I can wind up this class uh, after 10 minutes. It's your choice. Yeah, that's why I'm asking from you. That's if you want some preparation for the Xmas, so I can stop this class right now. You can prepare for the Xmas because festival is only in a 1 year. So if you think so, I can stop it over here. If you don't think so, your preparation are over, I'm over, then I can continue this class. It's up to you. So can I wind up this class right now? Okay, so this is what I ask from you. You can also tell me. I'm your teacher, not your supervisor. So you can tell me if you think so. So I can wind up this class right now. And Merry Christmas to you. Merry Christmas to you and your family. Okay. So there will be no class tomorrow. Thank you so much, Larry. There will be no class tomorrow. Now the class will be on day after tomorrow, that is on 26th of December, that is on Friday. All right. So bye bye. Merry Christmas.